Hello there. In this video, we are going to work on going through kind of a complex situation and seeing, based on the problem that is being presented and the questions being asked, of like how to use our flowchart in order to get our answers. So let's go ahead and take a look at it. So it says, Dr. Victor Marlowe, a renowned ornithologist and part-time motivational speaker, has recently been appointed as Director of Environmental Compliance at FeatherTech, a mid-sized drone manufacturer specializing in avian-inspired UAVs. Victor is particularly curious to determine how long it takes drone pilots to truly master the training course. FeatherTech's executive team has long claimed that pilots achieve full mastery within 10 hours of practice flights, a figure proudly displayed in annual reports dating back to 1985, next to charming pixel art graphics of their first drone prototype. Here they also mentioned that variance to achieve these results were 9 hours squared. But Dr. Marlowe is skeptical. The drones are now equipped with AI-assisted autopilot, advanced gyroscopic stabilizers, and laser-guided bird avoidance systems. Yet, tucked in the archives, he finds memos insisting that pilots must still practice loop-de-loops extensively to gain true mastery. To test the old claim, his team randomly samples 60 new drone pilots and record their time to master their training course in hours. The results were a mean of 11.2 hours. Okay, so we've got this set up. And one of the things that we have to note here is like sometimes we're given a big scenario, and there's actually only a few things that we need to key off of, like what type of data are we dealing with? Are we interested in looking at means or proportions, and some of the base values that are provided to us? So if we look at a few things here, let's start off with the very last sentence. It says, to test the old claim, his team randomly selects 60 new drone pilots and records their time to master the training course in hours. So we've got a couple things here. We know that the sample size is 60, and we know that we're dealing with numerical data because it's looking at in hours, and we're looking at results of the mean of 11.2 hours. So we got a little bit of information here right off the bat. Let's actually go and look at the first question real quick. So down here, it then says Dr. Marlowe wants to estimate the true mean mastery time and determine if the historical 10-hour benchmark still holds. So for the first one, we have at a 95% confidence level, what is the confidence interval in hours? I'm like, okay, so we've got some intervals here. Looks like we need to calculate a confidence interval. If we go to our flowchart, that is page number 3. And we can start seeing that our very first question that we have here is, are we dealing with numerical or categorical data? And we know that we are dealing with numerical data because we're measuring hours, right? Hours is a type of numerical data. And then we have to know, are we dealing with a population or a sample standard deviation? And that's all based on what is in our problem. So if we go back up to the top, we see that it's like, okay, FeatherTech made some claims about like it's past. So it says they achieve full mastery within 10 hours. And they also mentioned that they have a variance. And it's like, oh, wait a second. We know something about variance. We know that there's a relationship there. If you look on page 1 of the flowchart, let me kind of zoom in on this one real quick. We can see that standard deviation and variances are really closely related. Look, the standard deviation is sigma, and variance is sigma squared. Or if we're looking at sample statistics, the standard deviation is S, and the variance is S squared. So if we know the variance, we can get the standard deviation by taking the square root of the variance. So it looks like we actually have a variance, and it looks like this came from like historical records. It wasn't talking about a sample that they were taking. This was something that was being provided to us. So we know that the variance is 9 hours. So that's super handy. Let's start writing down a few of these things that we know. So we know that the variance, and we know that this is sigma squared, and we know that that equals 9. And so if we just want sigma, that is going to be equal to square root SQRT of 9. And that gives us a value of 3. Okay, so it looks like that we have a population standard deviation there. And now we can dive in to see how we calculate out our confidence interval. So we know that this is a population standard deviation. Let's scoot on over and let's see what are the key variables that we need, that we need to be looking for. drag this over just a little bit. There we go. Okay, right here at the top. So the first thing that we need to do is we need a confidence level. So our confidence level up here is, it gave us at 95%. Great, 0.95. Next thing down that it asks for is our alpha levels. Let's grab alpha, and that is equal to, we'll do 1 minus the confidence level. That gives us our alpha. Next thing that we want is our sample size. When we come up here, we team sampled 60 new drone pilots, so that is our sample size is 60. The next one that we need is our X bar, is the sample mean. And the results were a mean of 11.2 hours to master that training course. So we've got our X bar. We need a sigma and a standard deviation. Or, sorry, we need sigma, which is the population standard deviation. And I'm just going to drag this on, oopsies, down here. After that, we need a standard error. So we'll go with SE, standard error. And this is going to be norm.s.inverse of 1 minus my alpha divided by 2. And that provides me with my standard error. And then I need a z critical. And we're going to do z two-tailed crit. And in order to get this, we are going to do, oops, sorry, I mislabeled that. Standard error, what I did is actually the z critical. The standard error, if we read up here, standard error is pi divided by the square root of n. So let's do that one. Not pi, sorry. Sigma, the population standard deviation. Sheesh. Population standard deviation divided by the square root of the sample size. Okay, there we go. We got a standard error. We got a z critical. Now we can do our margin of error. We're going to do margin of error. Now there are two ways to do this. One, you can do this two-tailed critical times the standard error. Let's do that really quick. So we could do standard error times the two-tailed critical, and it gives us a margin of error of, roughly 0.76. But there's also this other version that we can do of confidence.norm. So let's try that. Let's do confidence.norm. And it wants us to put in an alpha value. It wants us to put in sigma. And it wants us to put in the sample size. So we got those three things, and it kicks out the exact same value. So there are two ways to get that margin of error. Now we need a lower value, and we need an upper. And from these values that we have collected, we are going to do our two-tailed, which is just x bar minus the margin of error, and x bar plus the margin of error. So let's dive in here. So we're just going to do our x bar minus margin of error, and then I am going to do x bar plus the margin of error. And that gets us our upper and our lower of roughly 10.4 to 12.0. And so that gives us answer D is our correct answer here. So we'll just highlight it as D. Okay, cool. Next question. So what is the single best guess of the population mean time to master the training course? And so we have some options here. Is it the population mean? Is it the sample standard deviation? Is it the margin of error? Or is it the point estimate? So this one is that our single best guess of our population mean is going to be the point estimate. We don't know what the population mean is. So we've gathered in our data and we make a point estimate, and it's our single best guess of the population mean. So if we are looking for a point estimate, the other thing that we could write this down is the sample mean. That is the point estimate. Remember that one. Now, if we are dealing with proportions, the point estimate would be the sample proportion, but because we're dealing with numerical data and we're looking at means, it's going to be the sample mean. Okay, next question. So it says, what would be the margin of error? Hey, we've already got this one. This one's actually pretty easy because we can just look down here at our margin of error, and it is 0.76. And so we've got our answer right away for the margin of error. And again, there are two ways that we can calculate out this margin of error. Let's scroll over just a little bit. We can see that our margin of error, you can either calculate all these variables and calculate out the z two-tailed critical and the standard error, and multiply those together, or you can do confidence.norm and the alpha, sigma, and n and plug those in. Okay, question 4. At the 95% confidence level, can Dr. Marlowe conclude that the mean mastery time is 10 hours or less? And the answer is no, because look at our lower and our upper. Our lower goes from 10.4 to 11 to basically 12. And 10 is outside of the interval. And in fact, 10 is below the interval, suggesting that the mean mastery time is greater than 10 hours. So we would say that no, because 10 is below the confidence interval. Perfect. Last question here is, what is the standard error of the mean? So this is another one just looking at our values, and it is 3.87 is our standard error. So that's how you kind of go through and do a confidence interval confidence interval where we know the population standard deviation sigma. Kind of the key things through here is looking really quickly, like, are we dealing with means or are we dealing with proportions? When you're dealing with means, you then need to go track down the standard deviation, where it's from. You might be given raw data. You might be given summary data like this. But if you're given the variance, you know that you can get the standard deviation by taking the square root of that variance. And then we can just walk our way down our key variables and calculate out our confidence intervals. Anyhow, hope that helps you kind of see one of these test style questions and how we can work our way through it.